Hi, I'm Tina from Prep 101. In this video, I'm going to review limits with you. There'll be lots of questions on both the midterm and the final involving limits, so I'll show you lots of tricks to look out for. Okay, let's get started.
Okay, so the first thing I want to go through to remind you of is the properties of limits that you would have learned in high school. So we suppose that the limit as x approaches a of f of x equals some number L, and the limit of x approaches a of g of x equals m. And then remember, if you have the limit of f plus g, you can just add the answers to each limit, so L plus m. So if this limit was 2 and this one was 3, we'd just do 2 plus 3 is 5. If we have the limit x approaches a of f minus g, we can do the same thing, L minus m. You don't need to write all these down. You'll get them in the prep book when you come to prep, but I just want to go through them just to make sure you remember them. Number 3, if we have the limit x approaches a of f times g, we can just multiply L times m. And the same thing works for a quotient. If we have x approaches a of f divided by g, we can do L over m as a fraction. And if we have the limit x approaches a of f of x to some exponent r, then we can do L to the r in our answer. That would work for a root as well. Square root would be 1/2 as an exponent. And if we have a constant in front of f of x, we can put the constant out in front of our answer. So the limit x approaches a of c times f of x would be c times L. And if we just have the limit x approaches a of x, then we put the a in for the x, and the answer is just a overall. So we're going to do a bunch of examples here. So example 1, I'm just going to write them out as we go. So if we had just a straight, easy limit x approaches 4 of root x, what would we do here? Well, we would just put the 4 in for x. So when you go to do any limit, the first thing you do is sub it in. Just sub in the number and see what you get. So we get root 4, which is 2. We don't get plus or minus 2. If they wanted plus or minus, they'd have to have a plus or minus in front of the root. A root by itself just means the positive answer. So number 2, if we had limit x approaches 1 of x squared plus 3x. Well, again, we always substitute the number in first. So we get 1 squared plus 3 times 1. 1 squared is 1, so 1 plus 3 would just give us 4 here. So there's nothing indeterminate about these limits. The ones we've done so far are just easy, substitute it in and get your answer. So same with number 3, limit x approaches 2, x squared minus 4 all over 5x. So what do we get here? If we put the 2 in, we get 2 squared minus 4 over 5 times 2. Now, a lot of people freak out when they see 0. So 2 squared minus 4 is 4 minus 4 is 0. But remember, this is 0 divided by 5 times 2, which is 10. 0 divided by any number is just 0. Okay, so that's not a problem. That's not an indeterminate form. So keep in mind, 0 divided by a number is 0. A number divided by 0 is either plus or negative infinity. It depends on whether the number is a positive or negative. Okay, if it's a positive number, like 5 divided by 0, then it would be plus infinity. If it was a negative 5 divided by 0, it would be a negative infinity. So these two are very important to remember. Okay, and the problem one, the indeterminate form that we're going to talk about first, is 0 over 0. And that's the one where we have to do something else. Okay, so in example 4, we've got limit x approaches 2, x squared minus 4 over 2 minus x. And so if I sub the 2 in there, I get 0 over 0. And if it's a long answer on an exam, then you always want to make sure you show what you got when you subbed it in, or you lose a mark. So be careful of that. So if we get 0 over 0, we have to think about something else to do. In this case, since we have x's and x squareds, we're going to look at factoring. Okay, so what can we do to factor? Well, x squared minus 4 is a difference of squares. So we have x minus 2 times x plus 2. And the bottom is 2 minus x. So the question is 2 minus x the same as this one or this one? Well, it's not the same as either. It's off by a negative. So if we leave the limit x approaches 2, copy down the top again. And if we take a negative out of here, then we switch our signs and we get negative 2 plus x. And negative 2 plus x is the same as x minus 2. The x is positive and the 2 is negative. So now we go to substitute our 2 in. 2 plus 2 over a negative 1, that's negative 1 right there. And so we get 4 divided by negative 1, which is negative 4. And that's our answer. So what do we do when we have 0 over 0? Well, there's a few things we can try. Number one, again, these methods will be in your prep book when you come to prep for the midterm, so you don't need to write them all down. Number one, always substitute x equals a in to see if it's indeterminate. If it is, then we can factor, like we did in the last one, the top and bottom and cancel. If there's a root, we can multiply by the conjugate, okay, if there's a root, so we'll talk about the conjugate in a sec. And sometimes if there's denominators, then you can factor and use a common denominator, okay? So factoring and canceling, conjugate, and then factoring and common denominator. Those are the most common methods. Now later, I'll teach you a method called L'Hopital's rule, which a lot of people would prefer, and that involves derivatives, okay, which we'll review in another primer video. Now the conjugate, if you have root x plus 1 minus 2, the conjugate would be root x plus 1 plus 2. All that happens in a conjugate, the root stays the same. The sign between the root and the other number, or sometimes between two roots, the sign just switches. So this negative 2 here switches to positive 2 here. Okay, so we're going to talk about a bunch of limits and how to evaluate them next. So for example 5, it's limit x approaches negative 1, x squared plus 3x plus 2 all over x plus 1. And if you sub negative 1 in here, you get negative 1 squared plus 3 times negative 1 plus 2 over negative 1 plus 1. And that would be 0 over 0. So we know at that point, okay, it's an indeterminate form, so we have to do something else. We see powers of x, and chances are we'll just want to factor. And I know factoring isn't a favorite method for people, so a lot of you will like L'Hopital's rule better when we get there. So leave the bottom alone. You can put it in a bracket and factor the top. So we're looking at two numbers that add to the middle, which is 3, and multiply to the last number, which is 2. So numbers that multiply to 2 are just 2 and 1. And so it would be x plus 2 here and x plus 1. And how does that help us? Well, now look at the top and bottom. We can cancel the x plus 1s. So now it's not indeterminate anymore, right? We just have limit x approaches negative 1 of x plus 2, or x plus 2 over 1 if you want to leave the 1 in there when you divide. So put your negative 1 into the x plus 2 that we have here, and we get what? Negative 1 plus 2, so we get 1. And that would be our limit, and that would be our final answer. Okay, so number 6, evaluate limit x approaches 2, x minus 2 over root x minus 1 minus 1. So put the 2 in. 2 minus 2 is 0. 2 minus 1 is root 1 minus 1. Root 1 is 1, so 1 minus 1 is also 0. So again, it's an indeterminate form. This time I see a root minus a number, so we're going to use what's called the conjugate. We're going to use the root plus the number. So we have limit x approaches 2. Put your x minus 2 in a bracket. We've got root x minus 1 minus 1. So we're going to multiply that by bracket root x minus 1 plus 1. Now, whatever you do on the top, you have to do on the bottom, and vice versa. Whatever you do on the bottom, you have to do on the top, so that we're not changing our question, because we're really multiplying by 1 here, because we have the root plus 1 over the root plus 1. So now, you have to decide, where do you multiply out? You never multiply out both on the top and the bottom, only one or the other. And in this case, we multiply out on the bottom, because that's where we have the conjugates of each other, okay? Wherever you have the conjugates of each other, that's where you multiply out. So the bottom will get FOILed out. The top will just get left alone. If you multiply it out, you'll make your life worse. It'll make it the question a lot harder. So we'll leave the top alone. Just copy it down. So we've got x minus 2 times bracket root x minus 1 plus 1. Now on the bottom, we have the root times the root. Root x minus 1 times root x minus 1 is just x minus 1. Root 2 times root 2 is 2. Root 7 times root 7 is 7. So root x minus 1 times root x minus 1 is just x minus 1. Now the insides and the outsides will cancel because we'll get 1 times the root and minus 1 times the root. So they cancel out. And so you never need to write the middle terms if you don't want to, because if you do the conjugate correctly, the middle terms will always be gone. And then last, first, outside, inside, last. Last is -1 times +1 is -1. So copy down your top again. So we have x minus 2, root x minus 1 plus 1. And what do we have on the bottom, really, once we cancel? Well, these are gone, so we have x minus 1 minus 1 again. And that's the same as x minus 2. And that's what helps us to finish, because now we can cancel these. X minus 2's are gone, and all we've got left is the limit x approaches 2 of root x minus 1 plus 1. And that's it. And now we substitute, no longer 0 over 0. So we substitute the 2 in and see what we get. And here we get the root of 1, which is 1 plus 1. And our final answer is 2. Okay, next I'm going to show you one that's a little bit harder that is common on exams. So this is a limit that involves an absolute value. So we've got limit x approaches 2, x squared minus 5x plus 6, all over absolute value of x minus 2. And if we put the 2 into the top and the 2 into the bottom, we do get 0 over 0. So we know that it's an indeterminate form. Now what you need to ask yourself is there's lots of different types of absolute value questions that they can make up for limits. So what you always want to ask yourself is the number that x is becoming here, x is tending to 2, does that make the absolute value 0? Okay, x tending to 2 does. 2 minus 2 makes that absolute value 0. So write down x tends to 2 makes the absolute value equal to 0, and that means you have to do both left and right hand limits. Now we'll do lots of different practice questions at prep, and so there'll be other examples where x tending to 2 won't make whatever the absolute value is equal to 0, and then we only do the limit of that number. We don't have to do right and left hand limits. But if the number that x is approaching makes your absolute value equal to 0, so if it was x approaching 3 of x minus 3, that would make it 0 again, and that would mean do both left and right sides. Now what you have to remember from high school is the absolute value of any number is always that number if it's positive. So the absolute value of 7 is just 7. So the absolute value of x minus 2 is x minus 2 as long as x minus 2 is greater than or equal to 0, which means x greater than or equal to 2, really. And the absolute value of x minus 2 is going to be negative of x minus 2 if x is less than 2. So that's the other case. So what we have to do is not only do we have to do right and left hand limits, but we also have to realize that if we do the x minus 2 absolute value is a positive, then that means just take off the absolute value and do nothing. If we're doing the absolute value of x minus 2 and it's a negative quantity, then we add a negative out in front of it, because the negative times the negative quantity would make it a positive. So that's what we have to understand. The absolute value of 7 is just 7, we do nothing. But the absolute value of -7 is -1 times -7. It's not magic. A lot of people come out of high school thinking you just magically make it positive, but no. You multiply whatever the number is in the absolute value by a negative, and that's how it becomes positive. So let's do the left and right hand limits. So we're going to do limit x approaches 2 from the right of the original function. And then we'll do the limit as x approaches 2 from the left of the original function. Now, from the right, we add a little positive sign. That means from the right. And from the left, we add a little negative sign. That means approaching from the left. And what happens is, we'll talk about continuity and limits at prep. And basically, what you need to know is that if the limits are the same from the left and right, then the limit exists. If the limits are different from the left and right, then we say the limit does not exist, okay? And then the graph is discontinuous at that number 2. So here, if we want to take the absolute value and x is approaching 2 from the right, well, from 2 from the right, if we look at a number line, 2 from the right is something like 2.1. you put 2.1 in here, 2.1 minus 2 is positive. So this is the positive case. And that means this is the negative case. So in the positive case, we know that we take the absolute value of a positive, we don't do anything, right? It's just absolute value x minus 2 is just x minus 2 if it's a positive. So over here for the positive case, we just take off the absolute value on the bottom and do nothing, just put it in a bracket. For the negative case, we have to add a negative because we know that the absolute value of x minus 2 is negative of x minus 2 if we're looking at a number below 2, to the left of 2. So this limit becomes negative of x minus 2. Okay, go ahead and factor x squared minus 5x plus 6 and see what you get. Hit pause and see if you can work out the two limits and see what you get. Okay, so we're adding to negative 5 and multiplying to 6. So adding to negative 5 and multiplying to 6, we get x minus 2 and x minus 3. And the factoring is the same on both sides. And what happens next is we cancel the x minus 2's. And over here, we have the limit x approaches 2 from the right of x minus 3. So we get 2 minus 3, which is negative 1. And over here, we have 2 minus 3 over a negative 1, right? That negative on the bottom means negative 1. So that's positive 1. And so the issue is, well, the limit from the left and right are not equal. So that means, therefore, the limit x approaches 2 of our original function of our x squared minus 5x plus 6 over absolute value of x minus 2, that original limit does not exist. Okay, there's two limits that you need to memorize for your midterm. For our final, you don't necessarily need to know them because you can use L'Hopital's rule. That's my preference. So, it's up to you. By the time you get to the final, you'll have different methods and you can choose your favorite. So one of them is limit x approaches 0 of sine x over x is equal to 1. And that would be the same for sine 3x over 3x or sine 2x over 2x. So any angle as long as it's the same on the top and bottom. And x approaches 0 of 1 minus cos x over x is equal to 0. So memorize those two limits for your midterm. So example 8 is a common exam question. So write this down. It says limit x approaches 0 of sine 5x over sine 2x. So I look back at this limit and I know that I want to have a 5x, sine 5x over 5x. And I know on the bottom I need to have a sine 2x over 2x. Because if they're the same, then they're both limits are going to equal 1. So how do I do that? Well, I've got my limit x approaches 0. So on the top, I'm going to say 5x sine 5x over 5x. Now, I haven't changed my question at all because I've added a 5x on the top and a 5x on the bottom, and those would cancel to give me 1. Same thing on a bottom, 2x sine 2x over 2x. Now, I want to keep this and this together. So I'm going to deal with the 5x over 2x first. First of all, the x's can cancel. And we know with limits, we can just put the 5 halves out in the front, right? That was one of our properties of limits that we talked about at the start. So we now have sine 5x over 5x all over sine 2x over 2x. And we have the limit as x approaches 0 of that. Well, now one of our properties of limits was that if we had the limit x approaches 0 of a over b, we could take the limit of each of them separately. So this limit over top of the limit x approaches 0 of the bottom one would be an equivalent answer. And so now if you look at the top of your page, those two special limits that you wrote down, well, the limit x approaches 0 of sine x over x is 1. That means also the limit x approaches 0 of sine 5x over 5x is 1. And limit x approaches 0 of sine 2x over 2x is 1. And so our final answer here will just be 5 halves times 1 over 1. So our final answer is just 5 halves here. And that would be the limit. Okay, that one is common on exams, and so is this last example here, example 9. So we have limit x approaches pi plus, so pi from the right, f of x minus 4 over x minus pi is equal to e to the pi. So write this down and take a look at it. And notice that x approaches pi. So if x approaches pi, then the bottom is 0. And the answer isn't infinity, right? So it's not a number over 0 is infinity. The answer is e to the pi, which is some number, right? So if the answer is some number, then we know that this must have been 0 over 0. And then we either factored or we used a conjugate or whatever, depending on the question. But it must have been a 0 over 0 in order to have given this answer to be e to the pi, okay? So if this was 0 over 0, then we know that f of x minus 4 has to be 0, right? X minus pi is 0 on the bottom, right? On the bottom we have pi minus pi. On the top, what would f of x have to be? Well, f of x minus 4 has to be 0, so that means that f of x had to be 4. And so it had to be whatever f of x is, it had to give us 4, because then 4 minus 4 would be 0 over pi minus pi would be 0 over 0. And then we would get some answer e to the pi. So now f of x is 4, so the limit x approaches pi of 4 would just be 4. And that's our limit.
I hope you found this video helpful. If so, see more videos in this playlist. Don't forget to join the Facebook Study Hub. Use the link in the video description box. Also, I hope to see you at my prep sessions, where I'll show you lots of tricks on how to ace your exam. I'll go through every problem that you need to solve, and you'll solve them with confidence by the end of my prep sessions. Many of our prep sessions are free, so go to prep101.com now for more details and to sign up. I hope to see you soon. Take care. Bye.